So up until now, this is a concept that has been foreign to you completely. So don't worry if at first it seems confusing, because it's not like when we're working with algebra or something. It's a completely different idea. Now, permutations comes into play when we're counting ordered selections and it's without repetitions. And we'll go into that later. But right now, I just want to define for you what permutation is. Permutations can be expressed in two ways. So here we have P standing for permutations, and then N for the number of elements, and R, which for that is counted. So what I mean by that is we can look at the other way that this is expressed, which is if you have NPR and N is N factorial, then it's going to be that number times that one number less than that times a number less than that for R amount of numbers. Yeah, so R just tells you how many of these you do. Okay, the other equation for your permutations with NPR is N factorial divided by N minus R factorial. Okay, and we'll see how these two are linked. In example 1, we have 10p3. So what we have here is 10 factorial, which is 10 times 9 times 8 times 7, so on. But the 3 tells us, so we only need 3 numbers. So it's always the first 3 numbers. So we have 10 times 9 times 8, and then we stop, okay? So only the first 3. And that equals to 720. Now what about considering using this equation? So here we have 10 factorial divided by 10 minus 3 factorial, okay? So this can be written as 10 times 9 times 8 times 7 factorial. So this 7 factorial can just cancel with that. And can you see how that leaves you with 10 times 9 times 8, just like that does here? Yeah? And that's why these two equations for your permutations are exactly the same. So there's two ways that I want you to consider permutations. So either in terms of this equation, which is N factorial divided by N minus R factorial, which is something I just want you to memorize, okay? So I want you to memorize this over here. And also in this way, which is just understanding it, which is with N is your N factorial and R is a number of numbers you need within that factorial. So here we only want the first 3 numbers of your 10 factorial. So that's 10 times 9 times 8. All right, so this is your basics of your permutations. So just remember, it's just a completely new concept. So it's okay if it seems a little bit foreign, but we'll work through some questions next that gets you a little bit used to working with this. So let's have a look at question 1. So here I want to evaluate a couple of these equations. So we have 9p2. So that just means 9 factorial, so 9 times 8 times 7, so on. But R equals to 2, which means I only need the first 2 numbers. So that's just 9 times 8, and then I stop. So that just equals to 72. Now what about 5p1? Well, that's 5 factorial, so 5 times 4 times 3, so on. But R equals to 1, so I only need the first number. So that just equals to 5. Nice and simple. Now what about 6p0? This is a bit confusing because it's just 6 factorial, but what's your 0 number? So we consider the other equation. So remember that was NPR equal to N factorial divided by N minus R factorial. Yeah? So then we have 6 factorial divided by 6 minus 0 factorial, which is the same as 6 factorial on 6 factorial, which equals to 1. Can you see how that equals to 1? So for some of these, you're going to have to use the other equation to work out. Now, what about 4p4? Well, that means it'll be 4 factorial, and I want all 4 numbers. So that'll just be 4 times 3 times 2 times 1, which gives you the same as 4 factorial, which equals to 24. Okay, what about 5p6? If you consider that just in this way, you can't really have 6 numbers when you have 5 factorial because you run out after 1. And when you consider it in this way, that's going to be 5 factorial 5 minus 6 factorial, which means that the denominator is going to be -1, and you can't have a negative factorial there. So in this one, it's going to be undefined. Now, what about for 5p -1? Well, you can't have a -1 number of a factorial. So in the same way, this is undefined as well. So you can see here that for most questions, you're going to be using this way to work it out. But for some of them, we do need to use this equation over here. And also for your future permutations, there is a button also on your calculator for this as well. So you see that as a big P, and you usually need to press shift or something and you'll get that up. So let's have a look at question 2 here. Here we want to find the value of n, and if 6pn equals to 120. And this is why you can't just know how to press the button on the calculator. You have to understand the concept of permutations. So over here, it means we have 6 factorial. So we have 6 times 5 times 4 times 3 times 2 times 1. But we don't know how many numbers of these are being used to make 120. So essentially we do a little bit of guess and check. So we think first this one, 6 times 5, and that gives us 30, which is incorrect. And then we try, what about the first 3 numbers? Yeah? 6 times 5 times 4, that gives us 120. So if we're using the first 3 numbers, that means that r here, or n in this case, must equal to 3. So therefore, since 6p3 equals to 120, n equals to 3. Yeah? So in this one, you couldn't have worked this out if you didn't understand the basic principle of what the permutation actually means. So now you know when you see this p, what it's actually referring to.